Next concept is arrangement of distinct objects. Question number 30. In how many ways 10 students can be sent to 5 classrooms?
Here in this question it is given that number of students are 10 and number of classrooms are 5, and we have to send these 10 students to these classrooms. So how to solve this? 10 students. So first of all I will call the first student, say Ram. I will call Ram, and how many ways I can deal with Ram? I have 5 classrooms, so I can tell him to go in classroom number 1 or 2 or 3 or 4 or 5. So how many ways I can deal with first student is 5 ways. Then I will call the second student. How many ways I can deal with him? Again 5 ways. Then I will call third student. Again 5 ways. So on I will call till 10th student and 5 ways. So total number of ways that I can deal with 10 students is 5 to the power 10. Often I have seen students used to get confused whether it is 5 to the power 10 or 10 to the power 5. To remember that, there is a formula. You can always memorize that. Formula is where to the power what. This is the thumb rule. Here in this case, where means classroom. How many classrooms we have? 5. To the power what? Students. What are the number of students? 10. So 5 to the power 10. You can get rid of the confusion. Or you can also do one thing, that in one classroom you can send one or more than one student, but one student you cannot send to 2 or different classrooms. So it is always where to the power what.
Next question is in how many ways 10 distinct coins can be put into 6 pockets. Here it is given that coins are distinct to each other.
Here in this case, question number 31, we have 10 coins. Please note that these are distinct coins. 10 distinct coins and we have 6 pockets. How many ways we can arrange that? So let us suppose we have taken first coin, how many ways we can put it? 6 ways. Again second point, how many ways I can deal with? 6 ways. Third point, how many ways? Again 6 ways. So on till last point, how many ways? 6 ways. So total number of ways is 6 to the power 10. Or again if we apply the same formula, where to the power what? In this case, where means pockets. How many pockets? 6. What means coins. How many coins we have? 10. So total number of ways is 10 to the 6 to the power 10.
Next is question number 32. How many distinct words of 5 letters can be made using the letters of English alphabets? So we have to make words of 5 letters in this case.
In this case, we have to make English word with 5 alphabets. So first place, how many ways we can fill up this place? 26 ways. It is not given to us that letters should be distinct. So again second place we can fill up how many ways? 26 ways. Third place again 26 ways. Fourth place again 26 ways. And fifth place again 26 ways. So total number of words that we can form is 26 to the power 5.
Next question is how many distinct words of 5 distinct letters, here we have to use this 5 distinct letters, can be made using the letters of English alphabet.
Here in this case we have to make again word with 5 alphabet, and these letters should be, alphabet should be distinct. So first place, how many ways we can fill up? 26 ways. Second place, only 25 ways. As we have already used one letter here, we cannot repeat the same letter here. Then this place we can fill up in 24 ways. This place 23 ways, and this place 22 ways. So total how many words we can form is given by 26 into 25 into 24 into 23 into 22. This is the answer. But if we solve the same question by different approach, so first out of 26 alphabet, if we select the 5 alphabet, we can select 5 alphabet in 26 C 5 ways. Now we have made a selection of 5 alphabets, and now we have to arrange them. How many ways we can arrange them? 5 factorial ways. Or we can also say this is equal to 26 P5. So by this logic we are getting answer 26 P5. But by different logic we are getting answer as 26 into 25 into 24 into 23 into 22. These two should be equal, as two different logics are giving us two different answers. Now let us extend this one. This particular thing I can write it down as 21 into 20 into up to 1 numerator, as well as the same thing in denominator, 21 into 20 up to 1. In other words, we have multiplied and divided numerator and denominator by 21 factorial. 21 factorial in numerator and 21 factorial in denominator. Then in numerator we have 1, 2, 3 up to 26, means 26 factorial, divided by, in denominator we have 21 factorial. Or we can also write it down as 26 factorial divided by 26 minus 5 factorial. By different logic we are getting this is equal to 26 C5 into 5 factorial. Or we can also write it down as 26 C5 is equal to 26 factorial divided by 26 minus 1 factorial into 5 factorial. Here is the proof of NCR. Here N I have taken in this example 26 and R I have taken this example as 5. So NCR is equal to N factorial by N minus R factorial. Sorry, it should be 5 here. N minus R factorial into R factorial. Here is the proof of NCR, and this particular question answer is 26P5. In this case we have to make words up to 5 alphabet. Up to 5 means maximum 5 alphabet we can use. So if we use 5 alphabet, then just now we have solved the previous question, question number 33. How many ways? 26C5 into 5 factorial or 26P5 ways. If we are using 5 letters. But if we are using only 4 letters, as 5 is the maximum limit, up to 5 letters. So we can take 4 letters, then our total number of ways will be 26P4. If we are using only 3 alphabet, then total number of ways will be 26P3. If we are using only 2 alphabet, then it will be 26P2. If we are using only 1 alphabet, then 26P1. Now, we'll do either this or this or this or this or this. This total number of ways is summation of these 5 values. We can make these numbers as a number of words.
Question number 34. How many distinct words of up to 5 distinct letters? Up to 5 distinct letters means we can make word of 1 letter or 2 distinct letters or 3 letters up to 5 distinct letters can be made using the letters of English alphabet. Now we will see questions based on arrangements of similar objects. Question number 35. How many words can be formed from the letters of the word apple?
Now let us suppose there are n articles. Out of n articles, p articles are same type and alike, q articles are same type and alike, r articles are same type and alike. Then how many ways we can arrange these n articles is given by a formula, and that is n factorial upon p factorial into q factorial into r factorial. Just for example, if I take n equal to 10, means I have 10 fruits. Out of 10, say p equal to, I am taking banana, I have 2 bananas. Q I am taking as apples, I have 3 apples, and R I am taking as mangoes. Again I have 3 mangoes. So total 3 plus 3 6 plus 2 8, and remaining 2 are 2 distinct fruits. Anything, it can be grapes, guava, anything. Then how many ways we can arrange that is given by the same formula, 10 factorial upon 3 factorial into 2 factorial into 3 factorial. So by using this formula, this is again a very important formula for arrangement of similar objects. So in this formula, now in this case we have to form how many words we can form this particular word apple. Here in this case we have 5 letters. Out of 5 letters, P is repeated twice. So total number of words that we can form is 5 factorial divided by 2 factorial. Condition is similar to we have 5 objects. Out of 5, these 2 objects are same type and alike. So total number of words that we can form is 5 factorial upon 2 factorial.
Next is question number 36. How many words can be formed from the letters of the word India?
Here in this case we have to arrange the letters of word India. Here we have 5 different words. So N is equal to 5 in this case. And out of these 5 words, I is repeated twice. So total number of words or distinct words that we can form is 5 factorial divided by 2 factorial, similar to that in the previous case.
Next question, how many words can be formed from the letters of the word banana?
We have to rearrange the letters of word banana. Here is total number of words we have 3 and 3 6. Out of these n equal to 6. Out of these 6, a repeated thrice while n repeated twice. So total number of words or total number of arrangements we have is 6 factorial upon 3 factorial into 2 factorial.
Next is question number 38. How many 4-digit numbers can be formed by using digits 1, 1, 2, 3? Here 1 is repeated twice while 2 and 3 used only once.
Here in this case we have to form a 4-digit number, and digits that we can use or numbers that we can use is 1, 1, 2, 3. So 4 different numbers, so n is equal to 4 here and 1 is repeated twice. So total number of numbers formed is 4 factorial upon 2 factorial. So total number of 4-digit numbers that we can form is 4 factorial upon 2 factorial.
Next question, question number 39. Let's consider the letters of word programmer. How many words can be formed that starts with M?
Here in this case, word that is given to us is programmer and total number of letters in this word is 10. Out of 10, R repeated twice and M repeated twice. Now condition is given that we have to form a 10-letter word. It should start with M. So 1M is fixed here. So now we can play with only these 9 letters. Out of those 9 letters, only 3 are repeated twice. M again we have only 1 available. So how many such letters word we can form is 9 factorial upon 3 factorial. Because only R is repeated. M we have now only 1. So total number of words that we can form in this case is 9 factorial upon 3 factorial.
Next question is question number 40. Let's consider the letters of word programmer. How many words can be formed from these letters only that starts with M and end with M?
Here in this case, similar to previous question, only thing is that the word should start with M and end with M. So M is already exhausted. Total number of letters now available we have is only 8. So N is equal to 8 in this case. And out of these 8 letters, R is the letter that is repeated thrice. So how many ways we can arrange these 8 letters is 8 factorial upon 3 factorial. So total number of words that we can form is given by 8 factorial upon 3 factorial.